All right, so we're back learning new material, well, with something old. So we're still going to be using L'Hopital's rule in this set of videos. We're just going to be doing it with different things than what we did before. So L'Hopital's rule says that if we are trying to find a limit and we get 0 over 0 or infinity over infinity, we can just take the derivative of the top function, derivative of the bottom function, and then retry our limit and see if that works out. All right, so that's kind of the first two forms of L'Hopital's rule, but there's a few more that are going to happen as well. All right, and these are the other forms, and they're kind of going to break down into three sections. All right, so 0 times infinity is kind of its own deal. All right, why is this something we can't evaluate the limit? All right, if we multiply anything times 0, it's going to be 0. If you multiply stuff by a big number, it's going to be a big number. So there's kind of two competing forces. Is it going to go all the way down to 0? Is it going to go all the way up to infinity? Or is it kind of level off? All right, the next one, infinity minus infinity. All right, there's kind of different levels of infinity, like x squared goes to infinity, but it goes a lot slower than an exponential, like 2 to the x. All right, so when you're subtracting infinities, is the second infinity going to win out and give you a negative answer? Is the first infinity going to win out and give you a positive answer? Are they going to kind of meet somewhere in the middle and level off? All right, so that's why we have to use L'Hopital's rule for that. And then the three bottom ones are all going to get grouped together because they have these exponents. All right, 1 raised to an infinity, well, 1 raised to anything is 1, but also a number raised to infinity should be a really big number, so they're two competing things. All right, anything raised to the 0 power should be 1. But infinity raised to any power should be a really big number. So there's all these competing factors, and that's what makes these things called indeterminate forms, because just by plugging in the number, you can't tell what your limit should be. All right, so we're going to go through in each of the next videos. All right, look at each of these cases and how you can use L'Hopital's rule, even though it's not exactly what L'Hopital's rule says, which says you need 0 over 0 or infinity over infinity. All right, so let's see how to do that.